The multiplication rule of probability will often be tested on the ACT. And the multiplication rule applies to probability scenarios when two events both occur. And that can be symbolized with the following equation. So the probability of A and B is equal to the probability of A times the probability of B given A. So I'm going to rewrite that with words, and you can see the probability of A and B is what that upside down union symbol means, equals the probability of A times the probability of B given A. This may seem like it's a little complicated, but really this is one of the easiest rules in probability. To really demonstrate how simple this is, let's do a couple of examples. Flip a coin 5 times. What is the probability of flipping heads, 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 tails, heads? To do this, we need to know the probability of, well, we have 1, 2, 3, 4, 5 events. We need to know the probability of each of those events. So the probability, we'll take the probability of flipping a heads first, the first heads. So the probability of a heads is equal to 0.5, so 50%. And we can apply that to all of the heads, so there's 4 of those. And then we have the probability of a tails. And that is also 50%, so 0.5. So now all we need to do is multiply these probabilities together. So the probability of the first heads, so we're going to go like this. Probability of heads, 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 tails, heads is equal to 0.5 for that first heads. And then given that we get a heads the first time, the probability of getting a head a second time is 0.5. Now, the probability of getting that third heads, given that the first 2 were heads, is 0.5. Now we need a tails, and the probability of that, given the first 3 were heads, well, still 0.5. And then finally, that last heads, so we need to multiply again by 0.5. So we just take 0.5 to the 5th is our answer. And that is going to be 1/32. Now, what if the events aren't independent? Well, let's take a look at example number 2. An urn contains 7 green lockpicks and 3 black lockpicks. One lockpick is drawn without replacing it, and then a second lockpick is drawn. What is the probability of drawing 2 black lockpicks? So, let's do this. So we want to know the probability of black and black. And then we'll put black 1 with a little 1 there and then a little 2 down there because we know we're drawing 2. So the probability of drawing the first black lockpick is equal to, well, we have 3 and then we have 7 green, so that's 3 out of 10. And then the probability of black, the second black, it's not going to be 3 out of 10 because we didn't replace the first lockpick. So the second one should be 2 because we removed 1 out of 9 because we, again, removed 1 from the total. So now the probability of that second one, given that the first one was black, is now 2 out of 9. So the probability of drawing 2 black lockpicks is now going to be 3 out of 10 times 2 out of 9. And that's going to give us 6 out of 90, or 1 out of 15. So again, what we did was the probability of black 1 and black 2, we'll set that equal to the probability of black 1 times the probability of black 2 given black 1, just in formula form. Okay, let's take a look at a third example. Roll a die and flip a coin. What is the probability of rolling an even number or flipping heads? Okay, so what we're trying to figure out is the probability of rolling an even number or flipping heads. Okay, so just looking at this, well, that doesn't look like the multiplication rule. This actually looks like the addition rule because we're trying to figure out even or heads. However, we do need to use the multiplication rule in order to solve this. So let's actually write out what this is. So the probability of even or heads is the probability of even plus the probability of heads minus the probability of even and heads. And again, that's the addition rule for events that are not mutually exclusive. And we know that rolling an even and flipping heads are not mutually exclusive because you can actually have both happen together. Okay, so let's do this. So the probability of even, so there are 3 even numbers on a 6-sided die, so that is 1/2. So the probability of even is 1/2. The probability of heads is 1/2 as well, so that's 1/2. And the probability of even and heads is where our multiplication rule comes in place. So the probability of even and heads is going to be the probability of even times the probability of heads given even, or we can say that's equal to 1/2 times 1/2, or 1/4. So the probability of even or heads is now, if we plug in all the values, is equal to 1/2 plus 1/2 minus 1/4. And that will give us 0.75, or 3/4.